A very good morning to all. Myself Bidisha Roy, Assistant Professor of CSE Department from Bengal College of Engineering and Technology. Here we conducting 5 days short-term training program, and this is the third day. STTPs are going on the topic of machine learning and data science, chaired by Mr. Sudeep Chakraborty sir, Assistant Professor of IT Department from Bengal College of Engineering and Technology. Today, our honorable speaker, Professor Dr. Kaushik Roy, represents his knowledge about this topic. He is currently working as a head in the Department of Computer Science at West Bengal State University, Barasat, India. He has published more than 70 research papers, book chapters in reputed conferences and journals. His research interest includes image processing, image computing, pattern recognition, medical informatics, image compression and manipulation, etc. So, now I would like to call Professor Dr. Kaushik Roy sir to continue this session to enrich our knowledge. Please, sir.
Thank you very much for inviting me and introducing me. So I'll be talking mainly on the topics of as the one of my research areas, handwriting document analysis. So I'll be talking on handwriting document analysis. Let me share my screen.
Yes, sir.
Is my screen visible?
Yes, sir, it is visible.
So I'll be talking on challenges in handwriting recognition and analysis of Indic scripts, a case study with Bangla. So this is formal disclaimer because whatever I'm saying is my view and it has nothing to do with my university. This is where I have collaborations with researchers in India and abroad. This is the where I work actually, as already explained by you. So I'm not going on this. This is the research team. As research work is a teamwork, so we also work as a team. And this is some of my team members with whom I work. This is some of my publications also has already been explained. So I'm not going on that. So as we talk of languages and script, I am trying to show you the languages used in the internet. As you can see, this is up to updated on March 31st, 2020. So English is the most used language in the internet, and this is 25.9%, followed by Chinese, Spanish, Arabic, and other languages. So can you find any Indic scripts out there in the chart? If you see here, you can find any presence of any Indic scripts on the used list. You can see Arabic, Portuguese, Greek, Indonesian, Italian, Ukraine. But unfortunately, Hindi is 0.1%, and Bangla being the sixth most popular language in the world is nowhere in the scenario. This is really unfortunate for us, especially we are working on these areas, especially on Bangla. So it's our moral responsibility is to enhance research on Bangla so that Bangla can be used by the native people of Bengali or West Bengal or Bangladesh for their day-to-day uses. So Bangla, also known as Bangla, an Indo-Aryan language, most widely spoken language of Bangladesh and second most widely spoken of the 22 scheduled languages in India after Hindi. So it is the second most popular language in India after Hindi and the native language of Bangladesh. Approximately 3 to 28 million native speakers and another 37 million as second language speakers are there for Bangla. Bangla is the fifth most spoken native language and the sixth most spoken language by total number of speakers in the world. Now you see where we stand and sorry and where we actually are. So we have been here, but unfortunately, this is not the scenario. So this is the Bangla and it has got some dialects, Bengali, Mavhuni, Baranti, Rahi, etc. The dialects used over the globe. As you can see, the color coding, Radhi dialect is mostly used here, and also your Manbhumi dialect is used in our case. Bengali dialect is also there in Bangladesh. Sylheti is there, Chittagaya is there. Okay, so this is how Bangla is actually formed. So in Assam also, in the huge part of Assam, there is also presence of Bangla language, also in Jharkhand. So top 10 language in the internet of million users. As you can see, we are nowhere in the scenario, right? So same in each of every data, right? So we need to do something here. It's our moral responsibility. So the scripts available in Indian context, as if we use this is, I think all of we possess this currency notes, and if you go through them, you will find that the languages official scripts are there written on the currency notes. As you can see, Assamese, Bangla, and so on. Hindi, Sanskrit, Urdu, then Tamil, Telugu, Malayalam, Odia, Arabic, and so on. Gurumukhi. This is Sanskrit Panchashatarupakani. So this is how things are going on. This is how the writing system evolves. We started our writing with fingers on sands, then on papers or leaves, tree leaves or tree covers. Then we started writing with pencil and pen, then typewriter, then PC and laptop, then again on the PDS. We are again started using our fingers. Also, now the concept of AI writing is also there, where we do not need at all any interface to write the text, and that can be transformed into a digital medium. Professor Pal of ISA Kolkata is pioneer in this area, and he's got some good works on this in this context. What we require a camera, and that's all. So handwriting analysis includes topics like languages versus scripts, online versus offline, recognition versus analysis, identification versus verification. So recognition, when we talk of languages versus script, as you can see in India, there are 22 official languages, but there are only 12 official scripts. This means what? There are multiple scripts, multiple languages that use the same script. For example, Bihari, Marathi, they use the Sanskrit, they use the Devanagari script. Assamese, Bangla, we share the same Bangla script, so is Manipuri. So online versus offline. When the data is collected some using some digitizer, where that relative time information is preserved, that data is also known as online data. For example, we can use any pen to write on a paper, but if this pen or the paper or there is a medium behind the paper which can record the current pressure position or coordinate or anything else, then that will be considered as online handwriting. Similarly, if you use your mouse to write something on the screen, that can be considered as online handwriting. And the when we write in a normal paper and use a digitizer to scan that to convert to offline one or to a digitized one, that is known as offline handwriting. Now, recognition versus analysis. By the time recognition means we just try to understand what is written out there or what is the actual characters, and they are equivalent ASCII code. But when we talk of analysis, who has written, why he is written, what was his mood, what he wanted to explain, how good or bad his handwriting is. So these are some of the characteristics that can be used for analysis of the handwriting. Now, identification versus verification. So handwriting not only serves as the information, it also serves as identity or a key in the biometric. So in biometric, we might identify a writer or identify a person or verify a person. So for identification purpose, if we find a page written by someone, can you identify who has written this document? So this is nothing but identification. This is one, M is to 1, 1 is to M mapping. On the contrary, verification, if I claim that this is, I have written this one or I have not written this one, how can you verify that I am saying what is correct or not? Or similarly, whenever you deposit or try to withdraw some money from your banks, and later you can say, I have not withdrawn the money. So how the banks will validate? So what they do, they take your signature and they match the signature with their with the signature that is stored on their database, and that is known as verification. They try to verify you after identifying you via your account number. So same thing is happening on other biometric modes like IDs or fingerprints and all. So as I was telling, language versus there are 8 scheduled Indian constitution. There are 20 official languages excluding English. 11 different scripts are there to write these languages. As number of script is less than number of languages, so many languages there are which have uses the same script. In example, Bangla script uses Bengali, Assamese, and Manipuri. Indic script follows alphabetic writing system, though Arabic or Urdu might vary. For characteristics of Indic scripts, presence of matra or Shirorekha for scripts like Bangla, Devanagari, Urdu script having maximum dots like small components, Oriya and Malayalam scripts having components of more circular shape. Many of the characters in Tamil script contain a T-like shape in their structure. Roman script contain many vertical and horizontal and slanting like strokes. Malayalam or Tamil and Telugu or Kannada can be distinguished by the direction of their concativities. In Malayalam or Tamil, most of the characters are present downwards, whereas the same lies upwards for Telugu or Kannada. So this is the writing system in Indic scripts. There are, if we talk of a national scenario, this is cyclic, alphabetic, and featured. So this is how things are organized. As you can see, Uriya, then Gurumukhi, Hindi, Bangla, they are of the same group. The scripts are Nagari group, whereas your Sharda is Gurumukhi group. Kannada and Telugu comes from Kadamba group, whereas Malayalam and Talim comes from Grantha group, whereas two alphabetic are Brahman and Abjad group is doing so Urdu and Arabic. Clear? So you can ask me any question at any phase if you have any queries, or we can take on after that talk also. Clear? So characteristics of Bangla in scripts, as I was telling, the presence of matra, Shirorekha in case of Bangla or Devanagari, dot-like components in Urdu or Roman scripts, carved spreads are on Uriya scripts, presence of dots in Urdu script. So the presence of T-like shapes in Tamil characters, Tamil and Malayalam, concavity and South Indian scripts. So online versus offline, captured using special devices like smartphone, tablets, OneNote, Slate, etc. On the contrary, offline are captured using scanner, mobile phone, or any other digitization devices. So what are the challenges we face when we talk of Bangla scripts? So as we can see, the Bangla, the shapes they are there. That some predefined shapes are there which we use to write the characters. For example, this is the shape. This can be thin in Bangla or three. If we talk in English, if we go give a matra, it will become to. If we extend this one, it will become o. Again, if we extend this one, it will become a. The number of strokes that is used to write this or component that is used to write this R varies from 2 to 6. This is as per our database. So we cannot claim that this is the standard rule because any more variations can be there. We never expected these variations while we started our work, but after analyzing our database, this is the variations we have found, and this is a more likely scenario because as we have considered nearly 1 lakh samples while analyzing these results. So for these combinations, if considering the main constraint theme, these are the possible combinations. Now we can understand how many combinations can possible for writing the same characters. The story is not finished yet. As you can see, this is the shape which is found in different positions. In the top, arm, akar. In middle, Madina Shaw. So this is Antisthiya jaw with presence of this one makes Madina Shaw. The absence of this one will make this Antisthiya jaw. In bottom position, Sahasanto. In upper position with this different orientation, this is ref. And multi-oriented segmentation they challenging because you can see this is going this direction, then change the direction. This is another challenge we face while working on Bangla characters. Recognition versus analysis. As I told you, recognition includes relation, OCR, OHR, syntax, and on the way, analysis involves behavior analysis or some other modes of analysis. Identification versus verification. Writer identification system needs to identify a particular writer using different quantity measures of handwriting from a pool of known writers, 1 to n matching, completely slower compared to verification systems. Writer verification system verifies whether two documents are of the handwriting are of same person or not. 1 to 1 matching completely faster compared to identification systems. Both are two types, online or offline. So individuality of handwriting, how as we are talking of analysis or recognition, so are the writing varies from person to person. So this can be seen here. The same writer writes same characters in different manners, or same writer writes different character in different manners. And you can see this is the different writers. The same writer writing the different characters in different ways. These are of same writer, but these are all same, but these are you can see there are same variations. These are from different writers. You can see there are variations. This is how the parts are formed, and this is the same writer. This is different writer. Some characters are overlapping, resembling that they are treated in the same way. Whereas you can see this character there is huge overlap. This is the characters different. We just write in different way. What we have done, we have superimposed the writing of different writers to make a word which resembles the different things. So for any research work, it's very essential to have a database first, and it's no different if we talk of handwritten documents. So this is what are the points we need to consider while developing the dataset. We have to develop dataset with printed, handwritten, postal, isolated characters on online, offline, word or text both on online and offline. Objectives includes cover the varieties of scripts and languages. We should have the variations considering on your ways of writing, the ways of variations, the possible combinations. For example, if we consider Bangla, we have considered only 59 characters, but the history does not end here. We have modified and compound characters. For example, if we do ko to acto, ko plus to, the shape is nowhere near to ko or to. It is somewhere o and another extension part of ko maybe. Or toirofola. It is a with the matra. So it has nothing to do with the a or koi shoy madana shoy koi. This gives another shape keo. Then the sum of the shapes which are totally different from the constituent characters. Or goiro shugo, talabo shoiro shu, you know how things changes. So this is how we collected the data. We have defined a predefined form and then extracted the content of this form. Practical. So this is how you collected the text. You have got predefined text and they are supposed to repeat. This text is defined in consultation with the Bangla department so that we can have optimized content considering all the variations. Because we have nearly 280 allograph shapes, excluding the basic shapes of 59 characters. So we have considered all these variations in our text. On the same day, we try to make a meaningful sentence so that the writer who is writing the text does not feel bored. Because the natural way of writing, capturing the natural way of writing was very essential for development of any system. So we wanted to ensure that the natural way of writing is ensured. At the same time, the variation is also covered. So we have got two parts here. One is simple where the modified characters are considered, and the other part is complex where compound characters are considered. This is about the multiscript. Multiscript again of different types as we will show right now. This is written in Bangla, this is written in English, so these are two of different scripts. But the thing is not so simple. As you can see, read command অনেক গুরুত্বপূর্ণ কাজ করতে সহায়তা করবে. So this means that in the same document, so in the previous case, the scripts of the document was one, The different document had different scripts, so it's a one type of multi-script scenario. But here the same document contains multiple scripts. Even three scripts can also be found. But in case of poster or syntax, you will find more than that also. So this is another example multi-script documents. As you can see, postal documents. Part of the text is written in English, part of the text is written in Hindi, or maybe Bangla, and so on. If we get the to remove the identity, we have removed that names from this one. So these are the sample images from our dataset, as you can see. So Bangla, Devanagari, Gujarati, Gurumukhi, Kannada, then Malayalam, Odia, then Roman, Telugu, Tamil, Telugu, and Urdu. This is our multi-level dataset. For the same text, we have got page level, block level, line level, and word level data. So this is some of the example of multi-script scenarios, as we can see in our railway coaches. Multiple scripts are there: Bangla, Hindi, English, or maybe any other combinations. Okay. This is another one from a document page, digitized using textbook. This is for the handwritten scenario. This is a mixed scenario, can be part of a. This is probably explanation of our Gita. So Sanskrit slogan explained in Roman. This is the dictionary, as you can see. This is the English, then Bangla, again English, again Bangla, and so on. So this is a text, and it's different writer how they are writing. You can see that variations in writing, the size, shape, extension part. This varies with writer to writer. So here you can see multi-step scenarios. There another one, noise. So this is another scenario. As I was saying, the nature of mixed script is also coming. I think all of you have seen this ad, Sri Hori. The Sri is written in Devanagari and Hori is written in Roman, though the dot is very difficult to locate from these shapes. So this is very common nowadays, as you can see in movie posters, in shop names, in Kolkata Film Festival advertisement, social media. This is very common. So this is part of some of our data. Text and non-text scenarios, as we need to identify text is there on a screen or not, then we can identify the content. As you can see, the address part, the destination part is this one, but this part is bigger one to making challenging. Part of the address is written. You can see some garbage is written here. There you can see the crosses are there. So the system, what will do? We'll identify we'll try to extract, detect the pin code box, identify the content of the box, and now we'll try to recognize and you can understand what will happen the result. You can see that this name for 70008. So the mixed nature is not even in word level, in the digit level also. Next are noises and other scenarios are there. Pin code is absent. This is for other languages, Roman data, Devanagari. This is the digitization process. This is some of the collected samples of our database. This is the characters, this is the words, this is the stroke. As you can see, stroke is the amount of data. This is applicable on online context. The amount of data that is collected from we start writing and before we leave the pen to start the new part of the character. This may be a character, maybe a part of a character, maybe a word, maybe a part of word, and one a part of multiple characters. So this is the stock database. We designed this one because as I was showing you out here that this part. So actually this is one shape, but these are using two parts. So the characters that are there, they cannot be they can hardly be found in actual text. So we need to collect the shapes that is available there and form the characters or word or text accordingly. So to develop any work, so we need to have a ground truth so that our developed system can be verified. But this ground truth generation system is very cumbersome and time taking. So what we used our developed systems to develop the ground truth, but again ground truth is supposed to be 100% correct. So we have used a semi-automatic system to generate the ground. This is the GUI of the developed system. The text is loaded. Then the lines segmentation module starts working. It tries to initially detect the lines. This is how they are detected, but they might not be accurate in always, as this was very good one, but not always we are so lucky. So for that, what we need to do, we need to modify this one. We use start point detection approach to minimize the time required to draw the lines, and with this approach, we could minimize the time required to 1/3 of the total time. So this is how the system worked. As you can see, there were variations in the way, and ultimately it could successfully identify the line, the path of where this line should proceed. This is the shape I was showing to you, which we successfully handled in our scenario. But still, there can be some issues, and for that we need to manually segment the line, and we try to minimize the human intervention. So wherever I click this, the from the left, the last drawn part, or from the border, it will be extended, and ultimately, if we don't have any other way, we need to cross the lines, and then segment the lines into words. We remove the matra for efficient recognition of the words, and this is how things are happening. Again, there can be some errors, and we need to group them up so that these unofficial words can be identified. So this is how things are happening. So this is segmented, and ultimately these characters are successful. So these two are of different part, but these are part of the same character, so they are grouped together to form the character. And this is how our system works. So same scenario is also for online, and I was telling that the points are captured. As you can see, this is how the pen is supposed to move to write these characters. Now you see the point, sometimes it is closer, sometimes their points are distance, because they're sampled at a fixed time interval. But when we try to move the pen in a circular direction, our movement slows down. But whenever there is a straight line, our pen moves fast, and that can be captured out here. As you can see, the speed it slows down. Now it is fast. Again slows down. Again it's fast. Again slows down, and again you can see. So this is the strokes. I use different color to show the strokes available on the word. CD. So this part is of the single stroke, Rossi are other part, position row with the single stroke, and dot and Rossi are the other parts. This matra is another part. So this is the character database for online character stroke database, and this is how you use to segment the lines. But sometimes there is issue that this word is broken into parts, and this word is also broken, and they are grouped up. So they need to manually segment, then from the word, from the characters, and then the words. So this is how things are going on. So this is not correctly identified. We need to select from the drop-down menu, and ultimately this is the GUI developed in MATLAB for the recognition of the text. And this is the ground truth generated from our sample data. This is the XML file generated for our data. And this is how our system performed while generation of the data. Now, when we have some skews on the text, then we need to correct this one and use the approach in courtesy to Govindra et al. For the same. Then feature extraction. There are different types of feature we have used. The directional strokes, the presence of dots, the compared lineage director, fractal geometry analysis. You can see the fractal dimension of the top or bottom cover is used to detect the scripts. And then keyboard filter, then your histogram of the gradient, basic histogram, 8 directional code histogram, then MFFT, modified fast Fourier transform, then GLCM, then discrete cosine transform, and have some Local handwriting based characteristics we also used to recognize the same. As you can see here, the interspaces, size variations, center of gravity, then your circularity ratio. You can see this is the minimum enclosing circle and maximum enclosing circle. Stroke direction, as you have used various directions there. We have used the morphological approaches here, the horizontal, vertical, and diagonal kernel used for the morphological operation on the text. And this is how we extracted the horizontal lines, the vertical lines, the slope lines. We will use water reservoir based concept, courtesy Professor Umapada Pal, IISc Kolkata. Top reservoir, bottom reservoir, water reservoir area, height, base point, baseline. These are the characteristics we computed from the water reservoir concept, and we have extracted these features from handwritten characters. As you can see, the water reservoir from top, left, bottom, and right direction. Profile based features, room and loop based features, pixel based normalization, reaction code. We also try to segment the words based on their precision, and we use the reservoir based concept to detect the precision, but reservoir based concept will fail if the words are not connected. So we have to connect the words first, then we have to use this one. This is the matra. As you can see, the presence of headline, but this way may measure fails if you have got slant. So we need to compute the slant angle first, then only you can proceed the same way. This is the baseline. This is for the online, the point-based features, normalized points, distance-based feature, fetch at distance, then hertz of distance, transit count, topological feature, crossings, then circular-based features, quadrant mass discriminant-based features, area and local features using quantitative-based segmentation. The segmentation is based on the weight of the content, an area feature, mass distribution, chord length, zone-based path travel features. Just 1 minute. Just 1 minute. Sorry for the inconveniences. Sorry. So these are some of the curvature-based features that have the results. We have obtained on character recognition. We achieved 97.8% accuracy on simple logistics. And these are some of the errors. Cho and Ho, Vivo and Roche, this one, Jaw, Ho and Do, and so on. This is on transit count features, which is up to 99.48%. With quantity-based approach, 98.5%. On character recognition stroke-based approach, we have used stroke-based strokes to form the characters from the constrained strokes and achieved very good accuracies. But this is how they are supposed to be formed. A stroke is the choi, which can be used to form choi, review, Roshu, Doshunoro, Do, Hashunoro, Borgiajo. So these are the shapes. This can be formed from this basic shape. Depending on this, we have used the tree-based concept as well as HM-based concept to recognize characters from the constraint strokes. In the segmentation approach, slant correction. Okay, so this is how we have segmented the characters. The segmentation again is the same way of the offline characters. The segmentation does not give you very good results. So what we do, the segmentation can have three issues. The segmentation can be proper, there can be over segmentation, there can be under segmentation. By over segmentation, we mean the system skipped some segmentation points where the segmentation should have been there. On the contrary, on under segmentation, over segmentation, we segment more than the number of segments should be there. And in under segmentation, we skip some segments. But if the segments cannot be found, it's very tough to recognize. So we use over segmentation rather than under segmentation. So in this case, you can see that the number of segments is 9, but number of characters are supposed to be 1, 2, 3, 4, 5, 6. So there are 3 characters which have more than one components. So they are merged to ultimately find the right characters or modifier shapes, whatever that might be. So digit recognition is was the issue in case of offline handwriting recognition because as I showed you, sometimes the languages are used a challenge. So rather than recognize individual script, because it is very tough to identify the scripts of the digits, we try to form as a combination. So we try to group Bangla and English together. While grouping, we found that Bangla 0 or English 0 are of same shape, so is Bangla 4 or English 8. We also found that English 2 and Bangla 2 of the similar shape, similarly Bangla 7 and English 9. So rather than having 20 groups in this combined set, we use 16 classes to recognize Bangla and English is combined, and then based on the context or majority of the digits, we try to convert them to which script they belong and actually have to find out the actual value, whether this is 4 or 8 or this is 7 or 9 and so on. And this is on the writer identification. We put boost accuracy on writer identification. This is for writer verification. This is the results we have obtained up to 98% of proposed approach. This is how we performed. So these are the scenarios where our system miserably failed. As you can see, the quality of handwriting poses some challenges in our approach. This is how for online recognition scenarios. The accuracy, as you can see, with point feature or curvature feature, the accuracy was not so good. So we have to fusion of the features, and you can see all the 4 scenarios. They have the first recognized character and the first choice. Then we combine them up to form the words using HMM-based approach, and top 5 choices were considered. And the sequential results can be found very encouraging. The systems which we developed includes recognition of input digits, script identification, character recognition, emotion. This is one of the encouraging works we are doing. It's the challenging also. So here we found that the mood of the viewer can be identified and suppose here this I am supposed to be happy mode, so the his curve goes up, whereas here the mode is not so good, so it's going down. So this is actually designed in keeping view of the development of a system for therapy of the mentally sick patients. This work is done consultation with the psychology department of our university. Hmm. Yeah, am I there? So the patient is supposed to view a video, and based on that video, the how much there is change on his or her emotion will be captured by the system, and based on them, the patient may be prescribed some videos which or audio which he or she might hear to improve his mind. This is where I develop some apps. We have also worked on movie poster databases, and these are some of the results. This is the argumentation for increase the data size and the recognition accuracy. As you can see, our system effectively detected the titles of the movies. Some of the scenario where the system failed. So as normal learning sometimes is not very enough, we work with deep learning based approaches also. Deep learning approach gives very good results, but the challenge is it requires very high database and high computational intensive approaches as the basic scenario, input, then feature extraction, then classification and output. But here, the deep learning, the image or the signal directly fed to the deep classifier and the recognition can be there. So DL is useful because of its information accuracy, as you can say, deep learning versus machine learning. But again, it requires time and data, high computation intensive machines and high volume of data. This is how things are happening. The convolution, this is multiple convolutions, then ReLU operation, rectified linear unit, and this is the design network for us. So this is the internal heat map of the various layers. These parameters, CNN architecture designed by us. Their constituent parameters, this is the net versus TNT net, and their combinations also used, and the performance can be seen much improved results on page ending Dataset, Multiscript 1963. So for building complete multilingual corpus along with benchmark results. So publishing works, you can go have some good journals in this area, PAMI and MLC and so on, transaction on IEEE, which are then SEM Talib and IIT Biometrics, IJPRI, IJDR, PR, PRL, etc. Conferences, CVPR, ICPR. This year we are organizing ICPR in Bangla Convention Center, Kolkata. The conference is first time organized in India, the 27th edition, and we are hopeful we will get support from you also. While publishing, you have to be careful because of open access policies. There are always threats are there, so you need to identify where to submit. You need to follow these standard indexing procedures, avoid paid or unindexed journals. So you have to have a trade-off. Publication pressure, funding issue, and pricing issue are there, but again, plagiarism is there. So any work without giving credit is plagiarism. You have to be careful on that. So any questions? I'll be happy to answer if I can. Any questions, please?
Thank, thank you very much, sir, for your lovely presentation.
Thank
And
you.
I'm asking all the audience, please submit your question in the YouTube chat so that we can handle your questions actually.
Sure, please.
Kindly kindly put your question in the YouTube chat. Hello.
Yes.
Hello, sir. Actually,
Yes.
regarding one question, that
Okay.
is, what is our entity Can you tell us something regarding entity recognition in Bengali language?
Entity recognition is actually not covered in this talk. Actually, entity recognition
Okay.
involves NLP, natural language processing work. So, entity recognition means what is it? It's a name. Whenever you have such a Ram. So, what is Ram? Is it that a name? Is that a place? Is that something doing or something? So, what is the meaning of this character? This word.
Okay.
So the context of this word. So this may be a name, this may be a work, this may be the characteristics. So these are what we use in the entity recognition.
And sir, I have received another question,
Sure.
the YouTube chat box.
Yeah.
That is, which model is best for extracting feature from an image?
Actually, I'm a bit confused because model, whether the audience wanted to know about the deep learning or the conventional machine learning. Because if you go with the machine learning, there is no such model to detect the features. There are approaches. There may be hybrid approach. There may be abstracted features.
Okay. Okay.
Or
Thank you, sir. Thank
okay,
you for enriching us and thank you for your speech. And
okay. Thank you very
right
much.
now, we are not receiving any other question, and all are appreciating your work
Okay,
and
thank
your
you very much.
speech. And thank you very much for enriching us, sir. Thank you very much.
Okay, sure. Thank you. I'm leaving
So,
then. Oh,
Okay,
okay.
thank you, sir. And regarding all audience, we are now concluding our session. Thank you very much for joining with us.